Hello and welcome to another online learning day. We will be starting Unit 2 for our Science 9 class. So that's why our first slide here says, stop, check in. So I want you to kind of think about Unit 1. Here was the main list of assignments that should have been turned in for grading for Unit 1. These were things that were worth 10 points or more, or were assessments. So if these things are not done, and you can find that out by looking on the Schoology gradebook, you should go back and finish these. It'd be nice to take care of this week, so then by the time we start next week, you're only focusing on Unit 2, and you can just confidently go forward. So take a look at this list of things, pause the video if you need to, or just go look in Schoology gradebook after this video, and just kind of think about, how am I doing with Unit 1? Am I done? Am I ready to move on kind of stuff? All right. So, speaking of, am I done? Am I ready to move on? Take a look at this big paragraph. So, this was something I showed you at the beginning of the school year to think about the big picture of this class. The stuff in red is where we've been already. Everything needs energy for stuff to happen. So, we started our class by exploring energy, storing it, transferring. We've talked a little bit about being efficient. Where we're going is the stuff that's underlined. Any change in the universe occurs because of energy. So now that we understand energy, we're going to explore more about our universe, especially how did it form and what is in the universe. So that is going to be our focus for this unit, and actually a little bit more in Unit 3 also. But for now, let's focus on the universe. All right, so let's get into it. So our plan for today, our essential question is to kind of introduce the universe. So introduce you to your universe. So what is the difference between solar system, galaxy, universe? And what are the definitions of the terms waves, wavelength, and frequency? Those are kind of our main focus things for today. For your bell ringer, what I'd like you to do is I'd like you to put the Unit 2 plan from Schoology, the folder today, September 30th, into Notability. That's going to be the thing that's going to get you ready for today, because then it also will set you up for looking at different parts of this unit. What are the assignments? You can fill out the dates for the different days that we're going to be doing things, just to kind of get you organized. So put that Unit 2 plan from Schoology into your Notability. Ideally, you have a Science 9 or Hour 1 folder or divider that you're using, and so you can put it right in there so it's easy to find for future reference. All right, so go ahead and set up your note page for today. Our topic is Universe Intro, and there's our two essential questions again. What is the difference between solar system, galaxy, and universe? And what are the definitions for the terms wave, wavelength, and frequency? You'll notice, or maybe you'll remember and notice, that usually I say you have to write down stuff in our notes if it's anything other than white. But you'll notice that I have a white background for this PowerPoint. So that means everything has to be a color other than white. So for today's notes, you only have to write down things in this color. So whatever color this looks like to you, to me, it's kind of like a kind of a reddish, lighter red, maybe reddish brown. So that's what you're looking for. So anything in black or this green or brown, those things you don't have to write down. So that's only the stuff in this color. So that would include our topic, our date, and then our essential question. So just a logistic thing for today's notes. All right, let's get into it. I'm excited to introduce you to your universe. So here's some things that we know. Here's some things we know about the universe based on observation, lots of years of studying, and things like that. We know that the universe has some type of structure. There's different parts to that structure, like planets and stars and galaxies and superclusters and supernovas and whatever else you know about space. But we know that there is structure. It is not just random things out there. There is structure. There is pieces to our universe. We also know that it looks the same in all directions. So if you can get out into space and you kind of do a circle or turn around, you'll see the same kinds of things in all directions, up, down, side, side. So generally we see the same no matter what direction we would be turning if you're out in the universe. We know that the universe is expanding and cooling, and we'll talk a lot more about that later in this unit. So for now, I'm just kind of giving you the big introduction. These are things that we know. And by we, I mean scientists, and by know, we have facts, observations, measurements, and things to support it. And then we know that it really has no edges and no center. Okay, this is where it starts to just kind of get like boggles your mind. Like, wait a second, how can there be no edges? Like, how can it just go on forever? How can there not be a center of something? This is the part that gets kind of tricky because we're inside the universe. So some things are kind of hard to study because we're inside it. It'd be like you were trying to describe what your house looks like, but you never left it. You were only inside your house. So trying to describe what your house or your apartment or your condo looks like, but you can never go outside of it. That's kind of the trick that we have to do for the universe sometimes. But because the universe is expanding, we can't really say that there's a definite edge or a center. And then the other thing is, based on our observations, we know that the universe is mostly made of the elements hydrogen and helium. So if you think about this thing called the periodic table, those are the first two elements on it. And then from those two elements kind of comes everything else. We're going to talk more about that later. But for now, this is our introduction, right? So these are the things that we know about the universe. So then let's do some clarifying definitions. Now, it is possible you already know the difference between all of these things, but we're just going to clarify or confirm. Let's think about the term solar system. We think about the solar system being out in the universe. So a solar system is a collection of planets, and there can be moons, and they orbit a star. So when we think about our solar system, oh, okay, so our 8 planets, including the Earth, our moon, and then, Jupiter has moons and other planets have moons, and then our star is our sun. So that's our solar system. So if there are other collections of planets and moons that orbit a star out in the universe, those would be solar systems. But then a galaxy is just a collection of stars. So we don't think of a galaxy as planets and moons. That's part of a solar system. So a galaxy is just a collection of stars. And then the universe is a collection of galaxies. So a bunch of different galaxies all together is what we think of as making up our universe. And then a planet is a body that orbits the sun. So again, that's within the solar system, which is inside galaxies, which is inside universe. Because remember, the planets and moons go around a star. Stars would be part of a galaxy because that's a collection of stars. Then galaxies are part of the universe. And then back to this idea that planets go into solar systems. So it's defined as a planet if it goes around a sun. And then the moon is a body that orbits another planet. So all of those things have just like relationships to each other. So it's easy to get them mixed up if these words are kind of new to you. So we want to make sure that as scientists, we use the terms correctly. So we're only calling it a solar system if there's planets and moons going around a star. We're only calling it a galaxy if we're talking about just stars. And then universe would be collections of galaxies, which could have solar systems in them. And then planets go around a sun. Moons go around a planet. Okay, so make sure that all kind of makes sense. You got kind of the difference between those different terms of stuff we find in the universe. All right, that's a good place for our first break. So level 1 question about our notes so far. Remember, you put this either on the side or you put a big bubble around it so it's easy to find it. Remember, Acasta level 1 is something that comes right from our notes. So we have a whole bunch of definitions that you could definitely use as Acasta level 1. You could also do a list. So list the things that are commonly found in a universe. That would be a great level 1 question because it's all those things we just defined. Planet, moon, galaxies, stars, those kinds of things. So go ahead and pause, do your first brain break, kind of think about the notes we wrote down so far. Okay, so let's summarize what we've done so far. We're not done. We're going to do a summary within our notes. We live on planet Earth. I know that's not a surprise. In the solar system, okay, that is part of the Milky Way galaxy, that is part of the whole universe. So again, that idea of, okay, so our planet in a solar system, in a galaxy, in the universe. And with that kind of idea, now what I just want to show you is I want to show you a whole bunch of pictures to help you get some perspective. Like, where do we, someone that lives in, or right now I'm at Roseville Area High School, you are somewhere in Roseville area, in Roseville or one of the surrounding towns, how do we fit into this whole idea of our universe? So I just want to share with you some pictures that I think are really cool to think about, like, what is our perspective? Where do we fit into this whole thing? So here's Roseville Area High School. Now, I know not all of you are at Roseville Area High School right now. None of you are, just me, depending on when you're watching this video, but think of just like the Roseville area. So that's our location in Roseville. This is our location in Roseville within the suburbs. So you can see like different other towns that are around us. So Falcon Heights is here, Little Canada, the like St. Paul would be down here, that kind of idea. So this is our location, this little dot here, the pin in the suburbs. This is our location in Minnesota. So you can see, oh, okay, so Roseville is about here compared to like St. Cloud, Minneapolis, Rochester, Wisconsin, Michigan. Okay, so that's our location in Minnesota. This is our location in the United States. So again, now you can see, oh yeah, Canada up here, the rest of the United States, we see different parts. So that's our location. Again, so we're perspective, we're zooming out. So there's our location in the United States. Here is approximately our location on Earth. So part of the North America continent. You can kind of see the rest of sort of our globe. Okay, so that's Earth. All right, so here's our location in the solar system. You can see the Earth, third planet from the sun. You can see different planets around us. Okay, so that's our solar system. Okay, now get this. This is what our Earth looks like, this dot right here, compared to the sun. Okay, so now getting perspective. So if you think of like where Roseville is compared to the Earth, and now where Earth is compared to this is the size of our sun, now you can really start to think about, oh my gosh, the perspective of the universe. And we're not even done yet. So remember, Earth is this dot compared to our sun. Now get this. Here's our sun. Think of like one pixel dot on a picture. That's our sun compared to other stars. Oh my gosh. Okay, so remember how big the sun was compared to Earth? And then now compared the sun to these other stars that are out different places in different galaxies, different places around the universe. Again, just trying to think of like the perspective of where do we fit in? Okay, now we're just going to keep getting more and more. Now let's just say, let's have like a small part of our star neighborhood, the stellar neighborhood. Let's just focus on like 33 stars that are common within the neighborhood and the sun being kind of in the center of it. So now you've got different things. And then we remember think of it as like the universe is expanding. So we're just focusing on the sun as our reference point, not that the sun is the center of the galaxy. So there's 33 stars. Let's zoom out some more. What if we do 260,000 stars? So again, the sun is our reference point, and then now we've got all these other different stars. So instead of 33, now it's 260,000. Okay, now what if we think about zoom out even more and think about like our part in the Milky Way? So again, we've got like our sun is kind of in the center of this, and then we've got different parts of that stellar neighborhood zooming out even more, thinking about our galaxy. Okay, now let's think if we could, our whole galaxy, 200 billion stars, and with our sun sort of at the kind of in that middle part of it. And then you've got this like circular motion of all these different stars moving and giving off light. And then here's the Milky Way, but here's the tricky thing. We can't really for sure know what the Milky Way looks like because we're inside it. So that's what I was saying earlier about imagine that you were trying to describe someone what your home looks like, but you could never leave your room. Trying to describe like where everything is, like you can by walking around, like you can kind of describe it, but to really know what it looks like, you'd have to be outside of it, and we can't get outside of our Milky Way. So that's kind of like the exciting, interesting thing when you think about space. And then let's think about our galactic neighborhood. We call that the local group. This is 700 billion stars, 3 galaxies, 46 dwarf galaxies. So remember, this was the idea of the Milky Way. And this is just kind of, so if the Milky Way now is at kind of the center of our focus, you can see that there's these different galaxies and different dwarf galaxies. Okay, so then we go even more 52,000 different galaxies, 700 trillion stars. This is a super cluster, so like a cluster of different galaxies, right? So we think about these different clusters. Where we fit into it. So we've got like these different local groups. So this was our local group, and then you've got all these other ones. Oh man, and then different superclusters. So now we're talking, are you with me here already? 60 million galaxies, 250,000 trillion stars. I mean, this is getting to the point where like our brain is just starting to like slowly slide down inside our head. It's just so much to even think about. But people have been studying this and looking at this. And eventually we get into what we think of as the visible universe. So 10 million superclusters, 350 billion large galaxy, and whatever this is, I don't even know what number this is of stars. Like this many powers of 10, a huge, huge number. But then you start to see kind of this like where we come up with like the circular idea of the universe, just because as things are clustering together, you sort of get this big idea. Now, this, of course, is theory, because once again, we can't get outside of our universe to for sure know what it looks like. But from all the stuff we've done by observing from the inside looking out, this is what we think of as our visible universe. What? Oh my gosh, this stuff is so cool. So I'm excited to kind of keep studying with you. That, like I said, was just kind of just giving you some picture, just sort of some ideas. So here's our whole goal in this unit. We want to put together the science pieces that explain why the universe is the way we think it is and how we came up with that idea. So I'm going to give you science ideas based on fact, based on evidence to build this thing that we call our universe. Okay, go ahead and take another break because that was, oh my gosh, that was so much to think about. So go ahead and do a level 2 kind of question. Maybe a sketch would be a great idea for this one, or kind of explain, why we think the universe looks the way it does, contrast a planet compared to a moon, like those kinds of things would be good. But go ahead and take a little break and just kind of think about all the stuff we've talked about so far. All right. So the next thing you might be wondering is, okay, so how did we learn about space? Well, the general idea is that objects from space give off waves that come to the Earth and we can observe them. Whether that's through like telescopes like this one or really, really powerful fancy telescopes, but we can observe those waves that come from space to the Earth. Or we can go out into space and observe one part of space from a different part of space. So things like space stations and landing on the moon and satellites, those things can also give us information that we interpret here on Earth. So since waves is really how we know about space, we got to just have some agreement on some stuff about waves. I would even recommend you draw a wave kind of like this in your notes. So here's the basics about waves. A wave is a repeating pattern of transferring energy. So there is a transferring energy is going from here up and down to some other point. So energy is being transferred. It's some type of pattern and it repeats itself. That's what we think of as a wave in science. So then wavelength is the distance from one point on a wave to the same point on the next wave. So when does the wave start to repeat? So if this is an up motion going down, this is still, now it's coming back up. Here's where it goes back down. So from this moment to this moment, that is your wavelength. Not from top to bottom, but from when it starts to repeat. So when it starts to repeat its pattern, that is called wavelength. And then frequency, kind of like the word frequently, is how much does it repeat itself? How fast does it repeat itself in a certain amount of time? So do I have 5 waves per second or 500 million waves per second? Would kind of give you the idea, oh, okay, if I have a lot of waves repeating, I bet my wavelength has to be a lot shorter so I can go a lot faster. If the wavelength is really, really spread out, probably my frequency is going to be a lot smaller because it's going to have to move a lot slower. So starting to see some relationships between energy and wavelength and frequency, which eventually will connect to like temperature and other things like that too. So that's just kind of what we think of as our wave basics. And then maybe you've seen something like this before, the electromagnetic spectrum. So you can see that when you have a shorter wavelength, you have a higher frequency, a higher energy. Those are things like gamma rays and X-rays. Gamma rays, that's the thing, if any of you are comic book fans, gamma rays were the things that changed Bruce Banner's body so that he became the Hulk. It's because there was so much energy. And remember, energy is the capability to do change. And so if there's a gamma rays, that's super high energy, it changed the cells in his body to become the Hulk. So even though, yes, it's a made up story, comic book, there is actually science behind it. Versus something like radio waves, these are your lower energy, which is good because think about all the different radio stations and radios that are playing at any given moment on every day, how many radio waves are around you. They're pretty low energy. So even things like cell phone towers and things like that that are sending off waves, that a lower amount of energy is not necessarily proven to cause problems in our bodies because again, the wavelengths are longer, the frequency doesn't repeat as much, and then you've got lower energy. And then you've got visible, so what we think of as our visible, so red is kind of the lowest wavelength that we can, or the longest wavelength we can see, and then you got like that indigo, violet, or purple is our shortest wavelength that we can see. So the highest energy color we can see is kind of purple, the lowest energy color we can see is red, and then you've got that rainbow, like Roy G. Biv colors spectrum in between. All right, let me just give you a little bit of more connection about waves in general before we apply it to science. So let's talk about light waves first. Sorry, before we apply to space, this obviously is science. Okay, so let's talk about light waves. So stuff that we can see. So generally, if you are seeing a high wavelength, so this would be a wavelength that is the wavelength number is really long, high. So it's like a long, stretched out wavelength. Then that's going to be like your red colors. A low wavelength, as in like a low number. So a small wavelength is going to be more like blue colors. Frequency then would be if you have a high frequency, meaning it is repeating itself a lot, so it's going really fast, those are going to be like blue colors. And then low frequency, meaning it's not repeating itself very much, that's going to be more like red colors. So that's light waves. So things that we can see in terms of color. For sound, so sound waves also act very similar to our waves we were just talking about. So again, just to kind of give you some connection between highs and lows wavelengths. So if you have a high wavelength, so again, by high, I mean the number is high. So it's a really long wavelength. That's going to be like a low pitch or a low note. So if you use something lower, right? So this is also kind of what affects why people's voices sound different ways. It's because of the frequency and wavelength of their vocal cords vibrating produces different kinds of sound waves. So if you have a low wavelength, and again, by low wavelength, I mean a small number measurement. So that means it is very, very like a small, it repeats itself very much. So then that's going to be high pitch or high notes. And then frequency would be, again, the opposite. If you have a high frequency, meaning it repeats itself a lot, that's higher energy. That's going to be your high pitch or high note. And then if you have a low frequency, it doesn't repeat itself very much. That's going to be low pitch, low notes kinds of things. So again, just kind of giving like this perception, like how do we notice waves in our everyday life other than the stuff that we see from space? Okay. All right. So the last piece of this is, all right, so we have this thing that we observe waves from space. They come down to Earth. What information can we get from those waves? So there's 4 things we can learn about space from studying waves. One is the distance to an object. So when you hear someone say that something is, 500 million miles away, that is based on actual observations from things from space. The temperature of an object. So if we say that the sun is, it's around 5,000 Kelvin, which is a super, super high amount of Celsius. That comes from observing the wavelengths from the sun. We can turn that into temperature. The elements that make up an object. So when I said that the universe is mostly made of hydrogen and helium, how did we come up with that? It's from studying waves from space. And then also the speed of an object. So when we predict how fast a planet is moving or how fast a star is moving through the sky, those kinds of things, that's again all from studying waves from space. So we're going to talk more about that later. In fact, this is pretty much most of our unit is trying to figure out these things. So again, giving you the pieces and the scientific evidence to explain how we know how far away are objects in space, what's the temperature of objects in space, what elements or composition of things up in space, and also speed of things in space. So that's going to be what we talk about more later. For now, this is your last brain break. So we're doing a level 3 kind of question. Put it in the side of your notes or put a big bubble around it so you can find it later for studying. And remember, level 3 questions are like you pull ideas from your brain, but it might not even be something specifically from the notes. So defend our universe. Is our universe good? I don't know. Predict whether or not there would be life on another planet. I mean, that's kind of getting a little bit beyond what we would talk about in this one, but we are talking about universe and thinking about the universe, so that's okay. So that's kind of your last brain break for today because we're done with our notes. So that brings us to the end of our first day of Unit 2. So here's the things I want you to get done. The first thing is finish any of the COSTA questions for today. For your summary is a special assigned summary. I want you to draw a picture. There was so much stuff we talked about that had kind of visual ideas in it. So draw a picture. And in your actual notebook, if you need to use your output page so that you have a big enough space, feel free to do that. Or put it on a different piece of paper and just tape it in your notebook. But I want you to post, so after you draw your picture, take a picture of it with your iPad and then post that picture in the September 30th folder, Universe Intro Media Album. That's what it's called. And that's how I'm taking attendance today. So I'll know that you took those notes or at least saw some of these notes by doing that summary and posting it in the media album for today. The other things you could be working on is remember that your video lab, which was our unit one, basically our unit one test, that is due tomorrow. So finish that up. Let me know if you have any questions. Send me a message. We can do a one-on-one meeting during office hours, or I can reply to your messages. And then remember that list of stuff from the beginning of this video. Any other unit one work, go ahead and try to finish that up today or soon, for sure by the end of this week. So this video lab due tomorrow, this other unit one work, let's say set a goal by Saturday, so that when you come back to class on Monday, you're ready to just focus on unit two, even if you're not quite done with everything right now. All right, so I will see you tomorrow for day 2 of unit 2 on Zoom. Thanks so much for listening. Bye.